So before we start, I had some few trivial questions so that I could get the context. So how many of you know about the GenAI stack which was announced during the DockerCon last year, last October? Please raise your hand if you know. Yeah. Okay. My next question is, how many of you know Neo4j is a graph database? Perfect. Thank you. And how many of you have heard about this term called retrieval augmented generation? Thank you. Quite a few. Thanks a lot. Welcome to the future of AI development. So today's topic was to understand the GenAI stack, which is a powerful toolkit which simplifies the development of AI-powered applications. So before we get started, why you should care at the first place, right? Why does GenAI stack matter to developers like you, right? So everybody know that GenAI is not just a buzzword nowadays. It is already proven, and it is changing the way how we interact with machines and making it more human-like, right? And by understanding the GenAI stack, you as a developer can really open up endless opportunities ahead and see how you can change how you interact with the machines, how you work, how you can increase productivity, how you can leverage GenAI to generate its code, right? And so on and so forth. So let's talk about some of the facts and figures. Goldman Sachs last year predicted that GenAI can boost the global GDP by 7% while doubling the productivity improvement over the next decade. And in the recent survey by Deloitte, they surveyed that 94% of the business leaders agree that AI is critical to the success over the next 5 years. And if I talk about the Google Cloud Next event, which happened during just few weeks back, they released a trend regarding the data and AI for this year, where they found that 71% of the organizations plan to use databases that are integrated with the GenAI capabilities, right? Just to introduce myself, I am the lead solution architect at Neo4j India, and currently I'm working with some of the top customers in India, and I'm all stoked to be part of this event today and just discuss what is the best way to develop the GenAI applications. Let's talk about the GenAI stack overview. So as a part of my job, I have worked with various developers during my tenure at Red Hat, Redis, and now Neo4j. And when I was working with these developers, right, and by reading various reports, by studying the industry trends, by knowing the application development principles, right, what are my takeaways? I found that if you wanted to build some next-gen AI application, it should have certain essentials and the characteristics where you should be able to get started with, right? And the first is if you are developing the application or whatever stack you use, it should be modular so that when you work across multiple parts of your AI components, it should work in harmony, right? And the second is it should be performant. That means when you run the AI models, it should be seamlessly able to run within your local machine as quick as possible, right? And third is they should support the RESTful API services so that they could work and integrate with the other AI services within the stack. And they should be scalable, because as and when the number of AI models grow within the stack or the data grows, they should provide the right flexibility and the scalability out of the stack. And then they should be open. They should be on some kind of open source model. They should provide the right transparency and collaboration within the AI community as a whole. And then they should be secure, because when there is a data in place, right, we want to make sure that it should be secured at each and every layer, whatever you use as a part of the stack, right? And then it should be data driven. So as and when the data volume grows, your AI application should be able to run seamlessly as and when you move to enterprise, right? Yeah, it should be AI centric. AI all the stacks should have some kind of AI strategy at its core, so that when you start integrating multiple pieces, AI is not an unknown animal as a part of the stock, and it can seamlessly integrate and work across the stack, right? And there are various tools available out there. So when you're getting started with developing this LLM application or AI powered application, you need to decide what should be the right selection of tools when you get started, right? So as I mentioned earlier, during the last DockerCon in October 2023, we as a team announced the GenAI stack, and this GenAI stack addresses some of the challenges when you start developing applications, where when you start integrating multiple pieces within the stack, right? You will face challenges, and this GenAI stack is devised to make sure that it addresses all the challenges when you start building the LLM application across multiple components. And the first in the pack is the LangChain, which simplifies the development of LLM applications. Second is the Ollama, where you can manage the LLMs locally within your desktop machine. And the third is Neo4j, which is the knowledge graph database for grounding the truth. And the last is Docker, which is now becoming a de facto standard for packaging, running, and sharing the application across environments. Just to talk a little bit about each one of them, so that you can understand how you can leverage multiple areas. I think Docker doesn't need an introduction. Most of you might be knowing it, and it's already proven in the market, and it is uniquely focused on the developer success, right? Why Docker in the first place? Just to reiterate, if you already know, right, they are very, very flexible, right? You can start developing applications in any programming language. They are very lightweight compared to the VMs. They are isolated. That means it provides same level of isolations, just like the VM environment. They are portable. That means once you develop the application, your application work across anywhere. That means cloud, on-prem, hybrid settings, anywhere, right? And it is stackable and interchangeable. That means once you build the application, you can run same version or multiple versions of application within the same machine. And then last but not the least, it can help when you're done with developing the application, you can just remove the container images, and it helps you save the spaces as well as computing resources, right? And these are some of the statistics where Docker surveyed across multiple organizations. And once you start adopting Docker for developing the application, you would see the similar success. Second is Ollama. Ollama provides the orchestration framework to run the LLM models locally within the desktop in both CPU as well as GPU modes. And it supports various large language models. If you know any of the open source models like Llama 2, Gamma, and so on and so forth, all of them are available within the catalog. That means based on your business requirement, if you wanted to just, if one model doesn't meet your requirement, you can just swap the models within one command. And even in the future is using the multi models. That means even if your business application doesn't work with only one model, it may require multiple models. Ollama can provide APIs to manage the life cycle of all these models within the local machine itself, right? And it is very easy to get started with. That means whether you are developing on Windows machine, Linux, or macOS, it works everywhere. And the best part of it is most of the developers, when they develop the applications using GenAI stuff, they are scared about putting the data in the AI online system, so that you don't need to worry about the risk of compromising the data. That means you can pull the model locally within the desktop, and then you can just play around with it so that you can develop your LLM application efficiently. And then about the LangChain, this is my favorite. So LangChain has been started way before the ChatGPT or the OpenAI just become popular, and it has been innovating in this space in a great way. So if you see, there are multiple layers in the LangChain, as the name suggests, right? For your any job, when you build the LLM application, there would be a set of jobs that would be performed in the form of chains, right? So it's like it helps you to simplify the development. That means when you develop the application, it will enable your application to make it more context aware from the source of data. That means with the techniques like prompt formatting or few shot learning or retrieving the data from the external database, right? It can help make the application more context aware. And the second is it can also make your application more reason about the data, where it relies on the large language model for the reasoning capability based on whatever context you provide as a part of the chain. And if you see, there are multiple layers as a part of the LangChain. So LangChain, at core, right, it is an extensible framework, and it integrates with myriad of components, and it provides the built-in runtime of those components to build the chains and the agents. And it also provides off-the-shelf implementation of the chains and agents, so that it is very easy to get started for some of the basic use cases. And if you see the LangChain community here, you can use it with the help of Python and JavaScript, where it has multiple modules. So first is the models IO, which is an interface with the large language models. The second is the retrieval module, where it helps you to talk to the external data sources. And then there is an agent tooling, where it lets LLM to decide which tool to use, provided there are some high level directives as a part of the flow. And then as a top, you can see there are LangChain templates. It has a lot of out of the box reference architecture, so that it is very easy to get started with. We also have a template for Neo4j. So in case you want to integrate Neo4j with LangChain, it's like it would be few lines of code, and you should be able to easily get started with. Then you can see there is a LangServe, where once you develop the application, it helps you to deploy the application with the right set of web API endpoints, so that users can immediately interact with the applications as soon as possible, reducing the mean time of the development cycle. And the last but not the least, which is the LangSmith, which is an end-to-end observability platform for the developers, where once you start developing the application, you can debug and test your LLM application, and further you can evaluate and monitor the performance, so that you can iterate over multiple versions of your LLM model and improve the performance and the accuracy of your application as quick as possible. And then the Neo4j. Neo4j is a leader in the graph database and the analytics space, right? If you see, it's not only the graph database, we provide the end-to-end graph data platform. And what do we mean by that is, like, as a part of the platform, it provides the native graph database. When we say native graph database, when we store the data, where relationship or the connectedness between the data is the first class citizen, that means we store this relationship natively within the disk, as well as end-to-end pipeline, right? How we develop the driver and the query language, it is very native, truly native to the graph database, right? So it provides the rock solid foundation for the platform, which is required for the enterprise scale, performance, security, and the data integrity for both the kinds of workloads, whether it is a transactional workloads or the analytical workloads. When we say transactional, it is also an ACID compliance, just like the relational databases. And the next is we also have a product called Graph Data Science. Graph Data Science really helps you to get more insights across the data which is available globally. That means if you wanted to understand what's important or what's unusual or what's next within for your business, then Graph Data Science and the algorithms which we provide can really help you answer those seamlessly. We have a 70 plus pre-tuned algorithms for both unsupervised and supervised machine learning frameworks. And then, just like other databases, we want to make sure that it should be easy to get started, so that you can do rapid prototyping as and when you start adopting the Neo4j. And then in terms of providing the graph database, we have all the things which is needed for you to develop the application. And then we also have the visualization and the discovery tool. That means if some of the users don't want to understand the nitty-gritties of Neo4j or learn the query language, they can just once the data is stored in the Neo4j, they can get the insights without typing any code or typing any query. And then about the graph query language support, just to give the context, right? In the database history, there are only two standard languages as of today. So first is the SQL, which was released by ISO in 1987, and second is the GQL, which was released last Friday. So out of 400 plus databases out there, there are only two standard query language which is released by the ISO, and it's the graph query language, and Cypher is the default query language within the Neo4j, where this graph query language was inspired from the Cypher. And we as a company has helped the ISO body to come up with the right construct on how this query language should look like, and it should provide the similar APIs just like the SQL. And then we know that Neo4j is not the only animal within the enterprise settings, right? So we provide various integration with JDBC plugins, Kafka connectors, Spark plugin, BI tools, so that whatever your needs is, whether it is batch, ad hoc, or streaming needs, you can seamlessly integrate with this other part of the ecosystem. And yeah, last not the least is like you can deploy Neo4j anywhere, be it self-managed or fully managed on cloud, or else self-managed or fully managed in your data center. We have all the options so that you can run your business anywhere around the globe. So in a nutshell, just wanted to reiterate, it's not just database, it provides the end-to-end platform to solve your various use cases, and provided talking about its capability and whatever essentials we talked about, it's the perfect database for your AI needs. Now, just to deep dive on the RAG, some of you mentioned that you don't know about the RAG. Probably I'll just talk about what is RAG and how it is relevant with the Neo4j, right? So before talking about the RAG, let's understand some of the limitations of the LLMs, where typically LLMs can generate responses which are not based on the training data, and this phenomenon is called the hallucinations. Most of you might be aware of that. This is really frustrating, right? And the second is LLMs typically are not able to verify the validity or timeliness of the answers, because LLMs are trained on the internal representation of the data, which is distorted. And based on the survey, right, even the advanced models from OpenAI like GPT-4, they can only verify the prime numbers in only 2.4% of the cases, and same is the pattern with the visual objects. And then LLMs are inadvertently follow the biasness within their trained data. That means it can generate the responses that could be unfair or discriminative or even unethical in some cases. And then certain widely used open source models are very sensitive to the prompt, so that even if you do subtle changes in the prompt setting in the few short learning model, you need to compromise with a lot of accuracy points. And it doesn't matter even if you increase the parameters of your large language model, or if you increase the number of few short learning examples, it is very sensitive to that particular aspect. And the last and the obvious, which is the lack of enterprise domain knowledge, right? Because LLMs are typically trained on the public data. It doesn't have knowledge of your private enterprise data. And to build the LLM application in the enterprise settings, having the right context is necessary, where LLM by default doesn't provide that. And the answer to this limitation is the RAG, where where why before you need to build on the RAG, you need to ask this is the big question which typically a lot of our customers ask when we start interacting with them, right? How you can leverage your domain specific knowledge so that you can build the accurate and contextual GenAI application. And we help him with this trend called retrieval augmented generation. It's slowly becoming the industry standard when you start developing the GenAI application for the enterprise need, because RAG really helps in augmenting the large language model by retrieving the up-to-date contextual external data, and it also helps to reduce the hallucination with the verified data, because you know your own data, so that when the LLM generate the answer, you know it is reliable and accurate. And then it provides the domain specific context. That means suddenly you can see that by implementing the RAG, the LLMs suddenly become intelligent on certain fields and topics which you require, and it also can perform certain domain specific tasks. And then also it enables the traceability back to sources, so that when it generates the response, you know that how the response got generated and where were the source of truth within your enterprise data store, right? Now, if you see that a lot of database providers are saying this message that vector DBs are the silver bullet for this problem called RAG, right? But when we talk to our customers, right, and we got to know that typical business requirements are way beyond a simple hello world kind of chat applications, which may require a lot of richness and contextual data from their internal knowledge which they have as a part of their multiple data sources. So while vector database are amazing at showing the art of the possible with GenAI, it has several limitations, if you see, and some of them I just wanted to list it based on what we learned from our customers, right? So vector database can only leverage a fraction of your data, because you cannot put all your data within the embeddings, because vector database in the end it only performs the embedding search, so you can only leverage the fraction of data. And because it only leverages certain data, it fails to capture the relationship, and where once you implement RAG with vector DB, you need to compromise with the quality and the effectiveness of your LLM application. Second is it misses the critical context, right? So if you don't have the right context within the database, besides the vector embeddings, your LLM application can significantly lag the accuracy which is required by bringing the right contextual richness of the data. And the third is vector similarity is not always equivalent to relevance. Just to give an example in layman terms, right? If there is an entity called Apple, right? Apple as a company and Apple as a fruit, both would be similar when you do the similarity search across this entity, right? But we all know that they are the different entities. And similarly, there are a lot of examples where you may not get the right relevance which is required to answer certain kind of questions. And the last but not the least, while vector DBs can provide some basic explainability, it doesn't provide all the details that why certain sources were retrieved over other. So in the end, you will end up with some black box data quality issues, which will deprive you from improving the LLM application and just iterate over the time. So while vector DB solves one piece of puzzle, it doesn't cover all the bases you need to build the GenAI stack. So I just wanted to highlight how you can perform RAG with Neo4j. So as Neo4j is a graph database, you can build and store knowledge graph within the Neo4j graph data platform, where it provides the storing of the heterogeneous and the connectedness of multiple disparate data, also comprising of the right relationship and the attributes. And this is very critical for the RAG application, which further improves the accuracy by having the right contextual richness of the data while generating the response, while LLM generates the response, and it is already proven in various academics. You can see there are a lot of research papers out there. If you see, there are tons of them in the last 1 year. So it's already proven in terms of various benchmarks. So one of the questions which we get from multiple customers and the users when they start building knowledge graph. So how do they build knowledge graph in the first place? So typically to build the knowledge graph, you will have data in the multiple sources. So first is you will have sources in the structured data sources, be it relational DB or the data warehouses, where we have built some out of the box ETL pipeline, as well as written some cool utilities where you can just import the CSV files and build the knowledge graph without understanding the underlying constructs of Neo4j as a database. And if you have unstructured data like the text document or the PDF files, then you can leverage some NLP techniques like named entity recognition. And few of the large language models are very good using these NLP techniques, where it can translate your unstructured data into the knowledge graph as quickly as possible within an automated fashion. So we as a company is also building one solution called LLM Graph Builder, where we are collecting data from our various customers to build the knowledge graph, where you don't need to learn all these advanced AI techniques and build the knowledge graph. And further, you can use the embedding models from this GenAI providers like OpenAI, Hugging Face, or this cloud providers, which can help you to translate other unstructured data like audio files, image, or for text document, where you can just translate into the embeddings and just store it as a properties within the node within the graph databases. And then we have something called vector database capabilities, where just like any other vector DB, we support the same approximate nearest neighbor search. And on top of that, once you have the similar nodes as a part of the result, you can further enrich the result with the additional relationship from the knowledge graph, so that you can have better response from the LLM. And we also support hybrid search with context, with the full text search, with the help of metadata filtering within the LangChain framework. And recently we have seen the trend, and there are some benchmarks by the Superlink, which you can see here, where they have created vectors of network information, which we call it as a graph vectors. So the traditional vectors are just for the unstructured data. Here we are creating the vectors for the structured data within the graph parlance, right? So with this setting, we, as per the benchmark, there is a reference available by the Vector Hub by Superlinked, where it says that you can have the 10x better hit rate when the relationships are a part of the knowledge graph embeddings, and you can find the correct answer within the first try more frequently as compared to the vector DB itself, right? And the last, we also have the graph data science capabilities. So it's like we are talking to multiple customers around the globe, and currently one of the customer is moving to the production settings, where it's a large investment firm. We are using the graph data science capabilities, where it helps you to get more insights within the business. So say for example, if you are developing an application within the supply chain or logistics domain, and if you wanted to ask the LLM that what should be the shortest path between two locations, or if I want to perform the route optimization within the supply chain routes, we have pathfinding and searching algorithm which will help you to do that. Then in the context of HR applications like an internal chatbot for the employees within the large consultancy firm, there are use cases where if you wanted to find employees with the similar skills, we have algorithms like similarity, right? And if you wanted to know if how many employees are working in certain projects like GenAI or across multiple projects, we have capabilities like community detection. And then if you wanted to understand who is the most influential employee, which can help in multiple projects or across projects, right? Then we have something called centrality algorithms, which will help you out of the box. And we are getting some amazing results, and it is also helping us within our internal LLM application, which is called the new agent, where it is helping us to build more explainable AI applications. And we are using algorithms like community detection and centrality to find how the user is interacting with the new agent internally within the Neo4j. And just to summarize, right, by unifying these three approaches of vector search, knowledge graph, and data science, it can certainly improve the RAG quality and effectiveness, and the graph RAG is the way to go. It's not only proven in the academics, but you can see that there are some quotes by Gartner where they have mentioned that half of the GenAI applications would be using models like knowledge graph or similar technologies in the next couple of years. And if you see the impact radar of this year, knowledge graph is providing the significant trend in the theme called model and data related section in this impact radar. And similarly, there is a recent research by Microsoft where they have done some kind of benchmarks with the help of baseline RAG with only the vector DB as compared to the graph RAG, where they have built the knowledge graph using the large language model. And also, unsurprisingly, graph RAG consistently outperformed the baseline RAG. You can just search about this Microsoft research, and you'll get the blog in the top 2 results in the Google itself. Now, just talking about some of the GenAI use cases, how we can build this multiple application on multiple fronts. You can use it for improving the customer experience or your internal employee experience by building tools like virtual assistant and chatbots. You can also build application who can generate multiple kinds of contents, be it unstructured or structured. And then the legacy search application based on traditional search methodology is getting outdated, and a lot of our customers started asking about how to perform the semantic search or enhanced search, right? How to bring the right personalization within when they ask certain question or when they search about certain things within the overall application settings, right? And then there are use cases around the workflow automation. This is very emerging, and this is very in early stages where your LLM application can make the intelligent decision making as well as it can further enhance the business operation. Say, for example, portfolio optimization in the financial services, or building the automated claim processing, or having the customer service ticket automation, or probably automating the maintenance workflow within the manufacturing industries, right? And then by building the knowledge graph, you can use it for many more use cases, which we are just getting discussed with various customers. And yesterday I was talking to one of our customers, and we surprisingly got to know that how they are using knowledge graph with GenAI. So we are just exploring more and more use cases day in, day out. Yeah. So I don't have much time, so I wanted to showcase the demo, but I would request you to visit our booth and see the demo. We can showcase the demo for this GenAI stack, or if you don't have time to visit the booth and if you want to attend the further sessions, what you can do, you can just go to the search about the Docker GenAI stack. You will get the GitHub repo, and you will just you can just run this demo by yourself. It's very simple to get started. And just I wanted to end with the conclusion that whatever essentials we discussed before starting this session, where does this GenAI stack component stand? Based on our discussions today, if you see, all these components are AI centric as well as open source, right? And Docker is already proven. And if you talk about Ollama, we discuss about various aspects, how it can support modular architecture, how it is provides the API compatibility, including the LangChain. And Neo4j definitely in terms of data-driven architecture as well as providing the right security, and it is more performant in terms of, because it's having the memory-centric architecture. I just wanted to end here, and I would just request to visit our booth to just see the demo and just I wanted to know if you are building GenAI application and how GenAI stack can help you to build the right application in place. Thank you.